Do you need an HDMI? I was told we need a HDMI.
Not us.
Oh, okay, good.
I mean, you know, if they're free, we'll take it. But
Oh no, sorry, you're the original and the replacement. Makes no sense.
you're absorbing. I'm sure there's something disturbing about that, but oh,
So I was, me and Jarl are going to run a betting pool as to how many people we actually get in this app session. Beyond me, Justin, and Jarl. Given the scheduling problem. And being in 2 meetings at once using VTECO doesn't help.
That's not a supported scenario, I'm guessing.
No, why? No. In fact, I don't think you can. Why? Being CFRG. You have to have 2.
yeah.
Maybe if you
Some
just-
people have more than one computing device, I've heard.
No, you have to have 2 data.
Oh, probably. I think it's time.
It is. Ready to start.
No, but let's go anyways.
This is really sensitive. Wow, look at all this transcribing that's going on.
Yeah.
Okay. So, welcome to the Jose Working Group at IETF 117. I think we're going to have a pretty concise and non-controversial agenda. First, as a reminder, this is the IETF. The note well applies. When you registered for this meeting, you agreed to abide by all of our policies and procedures and rules. If you have any questions about any of these, please see any of your co-chairs or our area director. Our area director is going to be a little bit late to this meeting, but he is following along. Just a couple admin notes I wanted to make. First of all, we didn't ask specifically for a scribe. There is a notes page that's linked from Data Tracker. Do we have anybody who's willing to be the primary person dropping notes in there? It's a small group. Can anybody take notes for us? Thank you. Also, I will note that anybody can actually follow along, and please contribute to ensure accuracy and completeness. I have developed a new appreciation for this tool because last time we apparently forgot to submit our minutes, and I didn't realize it until we were doing the meeting this time. It was super easy to go back and find the notes page and just upload them. So it's linked from Data Tracker. If you don't know how to find it, please shout. Second thing is, please, I know we're a pretty small group, but if we could use the Q tool, that would be great. Please be clear, concise, and respectful, and please remember to act according to the IETF Code of Conduct. Are there any, one last thing. For those of you who are old enough to remember blue sheets, because you either need to scan the QR code here, or you need to scan this QR code and join the meeting. This is the equivalent of signing a blue sheet to sign into the meetings. And it's very important that we have the attendance of everybody in the room, both for the intellectual property aspects of an open standards group and also for room capacity for future meetings, although I don't think that's going to be a problem. So I'm going to pass this around, please.
If you sign into MeetEcho, doesn't that?
If you sign into MeetEcho, yeah, sign into MeetEcho either on your laptop or use scanning the QR code.
If everyone doesn't sign in next time, we get assigned a telephone booth.
So, But they have decided that in the secretariat, in doing room counts, has observed that the number of people in rooms is greater than the number of meet echo counts that we have for each room, and that's why they have gone back to passing around a blue sheet. Next, this is our draft agenda for this meeting. Agenda bashing, which is what we're currently doing. Then we'll talk about the 3 drafts that have been accepted as working group drafts and have been uploaded to Data Tracker. Then we have a new individual submission, and then we have the rumor of an individual submission coming, and then any other business. Is there any agenda bashing? Nope. And then we will welcome David. So let me get your slides up. To share. This is your web proof updates.
Okay. This is my first time presenting at an IETF, so I look forward to being in front of a jury of my peers. So I'm going to give an update on the set of JSON web proof oriented drafts we have, the JSON web proof algorithms, and proof token.
Well, yeah, but point it towards this one. Yeah.
Oh.
Yeah. That doesn't mean that it will actually work, but
Yes, we tested it a minute ago. My experience with these things is they have not reliably worked.
Next slide, please. So between 00 and 01, we had some editorial cleanups, things that weren't quite coming out of the tooling correctly. We've also pointed to the latest BBS work that's going on in the CFRG. They may very well be talking about it right now over there. We have been getting a little bit more editorial feedback and comments on GitHub, which has been nice. Also, I've been working on the next proposal as an option to restructure things a bit. Next slide. Changes for O2. So we're, now that the BBS signature 03 is published, we're looking to fully embrace that. So the current text uses kind of a JavaScript library-based invocation for the older crypto. That has changed since, both in how it's described and what it does under the covers. So we're updating the text of that. We also had, a programmatic generation of all the examples from text fixtures. Those have kind of been hard coded for a while. So part of this effort is also to make sure that the examples are generated and correct. And following other people's lead, we will probably also publish any secrets or public keys needed for people to verify those in the spec itself. Next slide. Things we're working on after O2, the multi-payload stuff I'm going to present, whatever the resolution of that is, incorporating those changes. One of the possibilities there is in JWP that we restructure the presentation form to actually use that as well. We're still tracking the BBS work. It's one of the primary algorithms that we have to use to describe that's appropriate for our space, that isn't a commercial product, etc. They have new work that's proposed, which is proof bound. So the current text, I believe, uses a secret that you don't disclose. You do a proof of knowledge of that to basically carry the message forward. This would be based on a private key. And also there's been some interest, please talk to me about COSE equivalents of this work and getting that started. I think, is there another slide? So not too much to update on. Any questions?
Just a quick question. How many in here have reviewed the latest drafts? Okay. Is there a lot of activity on the GitHub repository for them?
I know Brent posted a couple of comments that we already accepted. The GitHub repository is part of migrating. I also want to triage existing issues. It's been there for a while, and I want to be a little bit more, get a little bit stricter about triaging issues.
Okay. I was just curious about getting some momentum to get this moving because the mailing list is pretty quiet and there's not been a lot of changes, but.
What I personally would like to see once we have BBS described using draft 3 is to start seeing some application of this. Just like with signatures encryption, it's really describing something that's part of a larger application, part of that use. So we really need to start understanding how people would like to use this and make sure that we're building the right shaped boat.
Okay, thank you. Any other questions? Okay, then we can move to your next presentation.
Okay, JWS multi-payload option. Next slide. So JSON web proofs today describe a syntax where there's multiple payloads delimited by tilde. This is using the same one extra character we have in the URL-safe alphabet that's used by the base64/unencoded payload option in more classic JWS. It's also being used to augment JWS messages for SD-JOT. In JWP, you have a protected header, and then you have multiple payloads delimited by tilde characters, and then the proof at the end. So this allows applications to represent multiple payloads. They don't have to necessarily compose it into something like a JSON message if it's, say, one of the payloads is a low-resolution JPEG. They don't have to base64 encode it in order to put it into another container or define a binary container. Proof algorithms proof algorithms in general want multiple payloads because they want to have payloads be the unit that they operate on for things like selective disclosure, eventually predicate proofs, which would be not releasing someone's birthday, but that they're over a particular age at a point in time. Applications still have to describe what's in those individual payloads. And there's another JSON proof tokens that starts to give one possibility of a starting point for applications, same as JOTS did for JWS and JWE. Next slide. So the idea of multi-payload option is to try to break that piece out of JWP and propose a way that all the existing JWS algorithms can leverage that tilde delimited syntax. So it's also an opportunity to more fully describe how that works in that sort of situation. So it describes both the context serialization and the JSON serialization. It describes how JWS signing output or signing input works for those classic algorithms. But it also starts to describe what we call a multi-payload aware signature algorithm, which doesn't take in the JWS signing input, basically as a whole. It takes the constituent pieces. So this spec attempts to describe interactions with things like detached payloads, that it doesn't really work, or that it works interestingly with unencoded payloads, and basically promote greater reuse between JDOS and JWP. Here's an example. Probably looks like a lot of examples you've seen, but non-base64 encoded header with a multi-payload true value saying that it's critical. The 3 payloads delimited by 2 tildes, I put them on new lines, and a signature at the end. Next slide.
Oh, the next one will be on there.
So there's not really that much new here. If you've read the existing JDP draft, since we're defining payloads as a new key for the serialization, that part's relatively straightforward. So the idea behind the multi-payload aware algorithms is that I'm now taking those individual pieces as octets and operating on them. So this provides a bit of a bridging layer between signature algorithms that don't have additional operations and proof algorithms which extend, basically give the holder additional capabilities for controlling the information disclosure. So the underpinnings of how it interacts, and I'd love feedback from various implementers on this. So it defines a new multi-payload protected header. It's similar to how base64 false for unencoded affect the validity of the overall compact serialization. For a algorithm that's defined as being multi-payload aware, the idea is that it's mandated to be true and thus can be admitted. And the reason this works is because a existing implementation, if it doesn't understand multi-payload aware algorithms, won't recognize the algorithm that's being specified there. That's a unique string. There's backward compatibility described as well. So the idea here is if I actually put, did I get that backwards? Yeah, if I do base64 encoded false for unencoded payload, then the signing input between the multi-payload and the unencoded payload are the same. They're byte for byte identical. So an existing JDS library will be able to take that data if you describe to craft your messages this way. And the payload with tilde delimiters would actually get passed up to a higher level for the implementer to deal with. So there's a bit of a call out for backward compatibility using existing algorithms like say ES256. And we also describe how this works with detached payloads, and it's in particular, they need to be fully detached. So don't have a mixed mode where one payload is in the message and the other 9 are separate. The application's expected to deal with all the payloads if they're not crafting a serialization with them. Next slide. Motivation. So primarily the motivation is the proof stuff isn't really leveraging the existing Jose stuff as much as I'd like. It's leveraging keys, it's leveraging protected headers and some concepts. And it'd be really nice to have the two blended together. So as I said, the proofs become multi-payload aware algorithms just with extra capabilities as defined by JSON proof algorithms. And JWP describes how to present new forms, basically to meet new application needs. Next slide. Some of this as well is making sure we don't have a deep dependency graph. It was not to talk about excellent work, but it was mentioned earlier today that the SD-JOT work, there is a desire to not have it be JOT only, even though it's built on top of JOTs, but to have JSON payloads be something that's understood in first class, because after all, it's really defining a redaction system for JSON and how to reconstitute JSON, other than describing a couple of keys and that the base is an object. It's not really putting a lot of restrictions on the actual JSON body. I would hate to see people say JSON proof tokens or something else that we build on top of all this is great, but internally I don't need that. I just need a traditional signature or an HMAC. This isn't even going to a holder. This is just data storage. But I can't use any of this stuff because it all assumes I'm using an algorithm like BBS. Yep. Oh. So if this is adopted, this changed the structure of the existing documents. So this would describe the forms, this would describe the concept of these multi-payload aware algorithms, while JSON web proofs would start to describe the roles and capabilities of the new proof-based systems, the idea of issuance of presentation, how those are serialized, how applications are expected to use them. Proof algorithms would describe these new multi-payload aware algorithms when they're proofs. So if someone wants to have a JWS just straight up signature that's multi-payload aware, they don't need to use proof algorithms. But this would describe how, what is selective disclosure, what is unlinkability, what are predicate proofs, the various different properties that individual algorithms that we know they can have, describe the security and considerations and privacy considerations around those algorithms with those particular properties, and describe algorithms that we know of that we think are broadly applicable and stable for people to use for proofs. Next.
Isn't that next?
Oh, there we go. Whereas JSON proof tokens actually gets dropped down and just becomes basically a multi-payload token format, somewhat parallel with JOT. So it can work with JWS or JWP. We're not describing how it works with JWE unless people find that interesting. So we'll have similarities with JOTs for hope. Not yet. So we'll have similarities with JOTs. Hopefully be able to reuse claim names where appropriate. There may be cases where it deviates, and describe the various properties of it with JWS, while today it's only really talking about JWP. I think that's I would love to get feedback on this as an individual submission. It's very new. Some people saw it for the first time when I submitted a couple of weeks ago. Some of them heard about it this week. So feedback on what people think on kind of this proposed restructuring, whether that seems appropriate, and then see if we can get working group adoption.
Okay. Ori?
Hi, Ori Steele. So just on the topic of JSON proof tokens.
Mhm.
One of the things that's been sort of difficult about SDJOT is like the compact serialization, the JSON serialization, the structured suffixes. For just as a sort of a comment for this work, it would be nice to be able to upfront know that we're going to have support for JSON serializations, we're going to have support for compact serializations. There's going to be consistency around structured suffixes so that it fits into the same sort of ecosystem as the work that's been progressing for SDJOT, so that folks who are taking advantage of, for example, the JSON serialization that SDJOT has that normal JOT does not have, are kind of aware that, yeah, you got selective disclosure and now you can get unlinkability and you don't have to lose your JSON serialization when you move to a token format that builds on this. Just keeping them all in line. I'm not sure if that's in currently, but it's a request for it to be in. I'm happy to leave comments on the document.
Things like media type aren't there. There's definitely already lessons learned, the checklist of things that we need to make sure we accommodate for. And it is still primarily meant, most of this is still primarily meant for usage with proof algorithms, things like BBS, ZK snarks-based approaches. We don't want to preclude it from working with traditional algorithms.
What's your comment on JSON serialization?
It's great. It's the best thing ever, and it's not wasteful. No, it's we are already with JWS and JV have things like unencoded headers. We have extensions where it is really nice sometimes to not have to figure out how to cobble things together with dots and tildes. So there could very well be scenarios going forward as well where applications say compact serialization is great, but it doesn't fit my data needs. I'm not a huge fan of it. I wouldn't choose it in a equal fight, but it is there, and it's there for people to use.
Go ahead, Michael. I'd like to point out to Mike Jones that that's the proper use of the queue.
Thanks, Mike Prorock here.
Mike confusion.
Dying laughing here.
There's some-
Yeah, exactly.
There's some confusion at the mic.
Yes. We're seeing replays of Peak Whip or whatever we're calling it these days. No, I just wanted to comment on some of the unencoded stuff and where I have particularly seen some interesting use cases coming up for that. And there's two different areas. One is in embedding material that's accessible from a structured data or otherwise standpoint for search engine retrieval, where you can verify that signatures are there and things like that. And that's just something that has been coming up, and that we're seeing that more and more. Build a lot of crawlers, and we actually are encountering that kind of thing in the wild, not just in images where we previously were seeing that stuff. The other area that stuff has come up in terms of seeing unencoded data is in similar cases, but in terms of like product listings and displays, right? So as we're seeing things around particularly carbon certifications or product passport type language, having the ability to represent in a well-defined way, this is signed data signed by me, here's some potential proof or information around it, around say a certification that this has, does help meet certain regulatory needs. So definitely liking the direction the work's going. I'm glad you haven't precluded those cases of saying, here's these unencoded JSON things. I'm not the biggest fan of JSON in general, but it has definite uses. So.
Yeah, and I actually have the same issue with unencoded payloads in the COSE case. And it's more along the lines that there's not enough application guidance of what's appropriate. So you don't want it to become an envelope for, I want to make a document structure, I want it to be COSE because that was my requirement, and oh, I can cram all this stuff in without bothering to sign it. There's the limits of how you should or should not use the unencoded headers. Um, it gets a little frightening sometimes when you hear someone has used them and say, oh, I hope they use them in a good way. But you can't really say, I hope they use them in the right way.
So
You use them in a good way.
there's a difference between unencoded payload and unprotected headers. Sounds like we might be mixing them up a bit here. Unprotected headers are really great for smuggling all kinds of information along with the integrity protected information, including information that is protected in different mechanisms. So for example, in the COSI use cases, counter signatures go in the unprotected header. In the SCIT use cases, proofs of inclusion for verifiable data structures go in the unprotected headers. If your base secured serialization doesn't have a unprotected header bucket, then those other sort of extension points the protocol person is looking for are not, you're not able to sort of pair them up. And it leads to the sort of issue of like, well, I'm not going to call what I'm doing a JSON web token because I have no unprotected header to put my extra favorite stuff in. And so my comment, before was just, I like the unencoded payload stuff because you do want to sign, images, you want to sign, arbitrary binary, and I don't want to have to base 64 your own code things just to sign them. But I also really like having this unprotected header bucket with the caveat of like, be super careful what you put in there, like make sure you're using it consistently with the other ways that you can put information there, and you just got to be super careful with it.
Right, and yeah, you're right. I may have misunderstood the two parts there. So unencoded payloads, the basic 64 false with this aren't really something I thought was appropriate to support because it's multiple payloads, because people might say, well, I want a mix. So instead, my motivation was more to push people towards using detached payloads for those kinds of scenarios and say, similar to how ST-JOT said, well, here's my own thing. Say you don't have to have everything in our format if you have special needs that we don't accommodate for. We have detached payloads. You can use this just as the protected header and the signature. My goal with the unprotected headers is I really don't want to have JWP have algorithms that require them to be used for like inclusion proofs. I want to make sure, like if I'm partially disclosing a Merkle tree, I don't want unprotected headers to be the place that you might put that data. I want to make sure that it's properly structured in the overall serialization. But yeah, I think for the unprotected headers, we're probably missing some guidance, and if people have guidance, that'd be great. And that's kind of a global JWS, JWE, and this work.
You could file comments and propose text.
Okay, any other questions at the mic? Oh wait, go ahead, Brian.
On the unprotected headers, there was a suggestion to do the ST-JOT disclosures in the unprotected headers, but when you have multiple signatures, the unprotected headers occur at that level rather than at the payload level. So it kind of like, it doesn't match up very well. I don't know if that helps you at all, but it came to mind there.
Yeah.
More generally, and this is not going to be particularly helpful, JWS is already painfully overloaded as a signature. A JSON web signature actually can be a signature in the classical sense, an HMAC, which is not a signature, but we call it that, and no signature at all, which is also not a signature. I'm still really nervous about further overloading JWS with even more semantics about being different things. And that, yeah,
Well, you know,
kind of go on record with that.
Yeah.
I don't know what else to do, but
yeah, well,
but continuing to propagate mistakes by making it more and more things, it can now be, it makes me nervous.
right. In the context of multi-payload, it's still signing that as a different form, but understood, you know, the debate for alg equals none rolls on forever.
Thanks for sharing, Brian.
So would multiple none now be
Multi-none?
multi-none?
It's all or none.
I don't see why none wouldn't be multi-payload aware. Some people will melt down, but unless we might want to say that you shouldn't use none with multi-payload.
I think he actually does.
Did you?
I will soon.
So I feel it sort of as my duty to remind people that we do have remote participants. And if you're going to speak, please go to the microphone. Have a lovely chat at the microphone, but use it.
So something that caught my eye is MP false and stuff about algorithms. It looks a bit ugly and non-orthogonal. And my question is whether you have considered having the inverse sense of the flag, like single payload false, which would have backward compatibility in one place instead of two.
Sure. Multi-payload false was there so that you could assume false with the default. If we inverted, then true would be the default. So if I have a JWS implementation that supports this and it doesn't see the multi-payload header and has a traditional algorithm, it would just assume it was false. But I can flip it, yeah.
Yeah, because if you flip it, you don't have to rely on applications failing on algorithms, which is what you said.
The protected header, if I have it as a critical to understand
Mhm.
header, which I did in the earlier example, and they don't understand it either way, they'll fail. If I don't mark it that way,
Okay.
then either way they would succeed. So it was more saying for forward use with proofs, you don't have to have a MP true in the protected header for all of these because those algorithms already make the assumption that they're going to be fed the individual payloads in the protected header. So you're not controlling it to understand one way or another. For traditional algorithms, they need to understand how to deal with the tildes in the payload and how to generate JWS signing text. So that's the purpose of that header, is to control the behavior of the existing algorithms. But yeah, we can talk more about whether it makes sense for it to be default true, default false, if it should indicate current or backward compatible behavior, because the base 64 header, for instance, the unencoded behavior is false.
Okay, any last questions? So if I could ask a favor, if you could send a link to the document to the mailing list and ask for discussion and any comments there, in addition to a link to the repository, you can put comments there as well. And then after there's been a little bit of discussion on the mailing list, we can consider whether there's, we can do a call for adoption if that seems appropriate.
Sounds great.
Okay with you?
Mhm.
Okay with
Yep.
you? Mike?
Hello, I'm Mike Jones. I'm going to do something that I've never done before at an IETF presentation, which I'm going to talk about a draft I haven't written yet. This is a proposal for a draft, hence there not being a draft identifier where it says proposed specification. Nonetheless, there's ideas here that I wanted to float by you, and let's roll. Next slide. There's two kinds of algorithms registered in the JOSE and COSE algorithm registries along a particular dimension, which I'll describe here. There's probably other dimensions, in which case that's also true. There's algorithms which I'm calling fully specified, that if you know the algorithm identifier, you know what cryptographic operations have to be in your library in order to use the algorithm. There's others that I'm going to call polymorphic, which don't completely describe the cryptographic operations that you would need to support to use them. So here's some examples. So the RSA SHA-256 algorithm identifiers in both JOSE and COSE are fully specified. ES-256K, which uses the Bitcoin curve, is fully specified. ES-256 in JOSE is fully specified. It says that you're using the NIST P256 curve. However, in COSE, it says you must support it with the NIST P256 curve, and you may use it with other curves, such as the brain pool curves with Cha-Cha Poly and other things that may come down the road. The other big example is EDDSA, which was the first polymorphic algorithm identifier registered for JOSE, which I admit I reviewed it and I didn't catch it, that you need to know the curve associated with the key, such as ED25519 or ED448, in order to know what the EDDSA algorithm identifier actually refers to cryptographically. This has consequences. Let's look at it on the next slide. Yeah, if you want to take a question, like,
Go ahead, Brian.
knock yourself out.
The ECDHES JWE algorithms, where would you put them in this classification?
That's a fair question. They bring with them the ephemeral key in the parameter set. And so you know at runtime where you stand, but it's a fair point.
As the receiver, you do,
Yes.
because you have the key and the algorithm. But as a sender, you don't necessarily. I don't.
No, you're raising a great question.
So as a sender encrypting to the receiver, theoretically you know what their public key is. So, I mean, it'd be hard to encrypt to a curve that I didn't understand with ECDHES.
This is a good discussion, and we should keep having it if we consider this draft. At a minimum, whatever the draft becomes, that absolutely needs to be discussed. Why does it matter? The OAuth specs, the OpenID Connect specs, the WebAuthn spec in the W3C, the FIDO2 specs, made the assumption that if you have an algorithm identifier, it's sufficient to negotiate between two parties that are going to interact cryptographically, whether they support a common set of cipher suites and can interoperate. The AS metadata RFC includes this example. Token endpoint auth signing alg values supported. Say that 5 times fast. With examples of RSA SHA-256 and ECDSA SHA-256 with the P256 curve. Those are fully specified. It's meaningful then for the other party to know what they need to do to use that token endpoint. And indeed, this actually started with OpenID Connect, and OAuth borrowed it, that there's a bunch of places we have supported parameters that say alg values supported or ENC values supported for this and that kind of cryptographic operation. And this is continued, for, I believe, things like token introspection endpoints and other things that have happened since that. Let's go to the COSE side of the house. EDDSA -8 is polymorphic. It can be used with ED25519. It can be used with ED448. It can probably use with other Edwards curves should they get registered. I think it was one John Bradley who noticed in the WebAuthn context that we had this -8 value and people were using it with 25519, but if people came to the table and wanted an authenticator with ED448 signing, there wasn't a way to say so, not using the negotiation framework that we have. And indeed, the line here is a quote from the approved WebAuthn level 2 spec, which just declares that if you're saying EDDSA, you actually mean EDDSA with ED25519. Were you going to talk, John?
Yeah, that person was actually, the person who was using it was me. So essentially, because we had painted ourselves in the corner with WebAuthn and CTAP, we either have to fix the algorithms or change the WebAuthn protocol to basically send a curve as an extra parameter to try and get around this problem. And I would rather fix the algorithms than try and wedge in a new parameter.
John,
honestly.
You're way ahead of me. Next slide. I have a proposed solution, which is register new algorithm identifiers that are fully specified for all the things that people want to do with the registered polymorphic algorithm identifiers. So for instance, in the Jose space, I might propose creating an identifier, which we could bike shed the identifier if we want, but let's not, called ES25519, whose definition is Edwards curve digital signature with the ED25519 curve. And we could have its animal friend with the 448 curve. And we could have COSE numbers associated with those algorithms that are likewise unambiguous. For COSE, where ECDSA was polymorphic or is polymorphic, we could do a similar trick. We could register a number, which I'm giving a name for the moment, which is ECDSA using P256 and SHA-256. And we could do the same with 384 and with 521 with SHA-512. And there's other examples which those of you who know the specs well, and particularly those of you who'd written code using them, you know what they are. That's my proposed solution.
I think we have,
Tobias is on the queue.
yeah, there's several on the queue.
Yeah, so in general, support of reducing or, creating more easy to follow guidelines for people willing to or wishing to register algorithms to not do that in a polymorphic way. I think that's a really useful thing to have documented. I just wanted to come back to the COSE one because recently, and Mike and I have discussed this, the COSE usage actually came up with ISO 18013 Part 5. It's usage of it right now. They specify using ES256 with the brain pool curves. And just reading the section, because I don't think this text is absolutely clear, but my interpretation of it at least is that it is not allowed because, and I'll read from the draft.
You're reading from the COSE standard.
I'm reading from the reference standard that the IANA registry points to. This document defines ECDSA as working only with the curves P256, 384, and 521. The document requires the curves be EC2. Implementations need to check that the key types and curves are correct when creating and verifying signatures. Future documents may define it to work with other curves and key types in future. I take that to mean those other documents would register other algorithmic identifiers, right? So ES256 is...
That would be the hope, but I don't think that's what it means.
Really? Okay.
Michael? Oh, wait. You want to say something?
So that doesn't mean that if somebody wants to use the brain pool curve with ECDSA, we can't accommodate them by registering a new algorithm, which would be the less brain exploding portion of that.
Yeah, Mike Perrock. Thank you, Michael, for putting this draft idea together, concept. I am broadly supportive. We had the post-quantum use in protocols, or whatever that is now, since we can't seem to get a name that rolls off the tongue over there. Yeah. Anyways, right before this, and it was actually a good session, and we're talking about the variety of drafts across the board. But one of the things, there's a couple of things coming out on that side. One is a great draft that deals with naming of hybrid schemes and things like that that are coming about. Obviously, a topic that will be important. In general, if I think about the challenges we've had just with getting folks to understand that lattices are not curves, and this would have helped quite a bit there, right? And so having this clarity, especially as we are seeing new and many and varied post-quantum approaches, much less before we get into hybrid signature schemes, which unfortunately are happening, whether we like it or not, usually not. So it's just something we should be aware of, and bad things will happen eventually because someone will take combinations that are really improper together if we don't provide this ability to register very clearly what we mean when we say it. So I think this is a great step in the right direction, not without challenges to go through and break some things out, but I would be broadly supportive and willing to review and contribute. So the other snark I just wanted to add is, are you sure we don't need to put year names in these things for when we coin them?
Oh, sit down.
So taking the prerogative of being at the mic, I'm going to connect something that Mike Prorock just said and something John said a few minutes ago, which is John said, you know, we could maybe fix this by augmenting WebAuthn to maybe, for instance, pass a curve parameter. And Mike just said, there are things other than curves. There are lattices. There's HPKE parameter sets, which are not all curves. And cryptography is a big bad world, and none of us, maybe some of you are cryptographers. I'm not.
Justin Richer. So two parts to this. One positive and one negative. The positive is that back when we started working on HTTP signatures, which has its own algorithm registry, kind of things like that, we actually went and had a conversation with CFRG about this, and the overwhelming feedback that we got was make sure that all of the code points fully specify every single variable part of this algorithm. And so that has been encoded in the HTTP SIG draft of if you are defining an algorithm, whether it's registered in IANA or you're just using it locally, because you're allowed to do that with that spec. It's a little bit different world. You have to lock every single thing down. Your hashes, your padding generation function, if you've got one, anything.
Your KDF.
Yes, absolutely. Anything that could vary has to be locked down and understood and defined by the application. And if you're using one of the interoperable code points that's in the registry, the text that defines that absolutely has to do that, including bytes in and bytes out, in order to actually make this thing work. So yes, I absolutely agree with this approach. This is not a place where polymorphism is particularly helpful. Like you don't want variability here. That said, this work would make things a little extra weird, because without an additional for working with these various algorithms, because without sort of an additional flag or identifier or indicator or something, I now have algorithm values which could land me in the same space in two different ways by meaning two slightly different things. So I have two ways to pass the same information. And when you're talking about registered values, that's usually a bug. Now, if we had started where this was like how everything went in and the guidance going in was, like what CFRG suggested, then we wouldn't be having this conversation, obviously. But we live in a reality where that does exist. And so I think part of this work would be questioning, should there be a deprecation of the underspecified algorithms in favor of these? I know there's oofs coming from the audience for the remote participants. And some cheers, but I mean, it would be painful to do, but also might be the right thing to do. I'm not sure.
I'll touch upon that on the next slide a little bit.
All right.
Thank you.
Excellent. Thank you. Or just in general, how would we handle this reality where we have these things that mean two really kind of different things, where the whole point of a registry is you get one thing and it means one thing?
Hi, I'm Daisuke Ajitomi, and I don't hesitate. I don't dislike polymorphic algorithm, but I don't have any reason to opposite this proposal. Yeah, but I think it is relatively easy for signing algorithm, but it is I think it's very difficult for ECDH things. And I have a question. Will you also include encryption algorithm for ECDH? I think you want to include the curve information, but I want to ask you, you want to include the subsequent encryption algorithm into algorithm ID. Do you understand that?
I do understand the question. I think somebody else, maybe Ori, asked that question, and Brian just asked the question about ECDHES. I
Yeah.
have not fully thought it through, and I would welcome those who care and those who have informed opinions to be part of that conversation, because I do want us to do a thorough job, but not overcomplicate things. Thank you.
I think he was also asking about sorry, and this may not be accurate, but what Ori and I were, where I was, and Ori followed on was about ECDHES specifically. I think that question also involved whether the actual symmetric content encryption algorithm would be part of the construct, which is an even bigger issue or question that I don't have an answer for. But
It is the case that Jose and Jose do split things up so that there's two parameters. There's the key establishment algorithm, which is ALG, which may be ECDHES or some other things, maybe direct. And then there's the content encryption algorithm, which is specified as ENC. And I would like ENC to be as fully specified as I'm saying I want ALG to be for the same reasons. ECDHES, key agreement is an interesting space, and I think we should do a good job of this, because I don't want to leave a mess that other people will have to clean up some years from now, like I'm attempting to clean this up with your help.
Awesome. Yeah, so I think Ajit-Hogasan's question's been answered. And I just wanted to say of the registries, I think it's great to have registries that are so fine-grained that you can very clearly identify each individual concept independently. But it doesn't necessarily mean that, that's a good idea to expose that kind of registry in an envelope protocol environment, depending on the scenario. And so I'm supportive of this, but I'm also sort of supportive of some of the other registries that we've discussed. I mean, we've talked about this a lot in the context of HPKey and this concept of, hey, was it a mistake to have ALG and ANC be separate? We could have made a single identifier that communicated both those concepts. We didn't originally. Should we put them together? You could. I think those are the kinds of conversations that's good to have, and it's easier to have that conversation when you can point at each of them individually somewhere, but that doesn't mean that you need to always be pointing at them, in that way. So I think, and just some commentary on, hallway conversations I've had with folks about this sort of experience, and this particularly the CFRG comments, my summary of, or my sense from folks who work within CFRG is that they think it's good to fully specify these things and communicate the intention with as much simplicity as you can possibly muster into the experience. And that is a design constraint that runs against some of the sort of registry maintenance design considerations or agility design considerations that you might have. So you have to balance these issues. But from my personal perspective regarding the IETF and this registration process, the debate, the time that it takes to write a draft and update a registry entry to add a new capability is probably shorter than the debate time it takes to support a fully parameterized protocol. That's it.
Okay, couple of non-chair observations. So we also need to consider Edwards encryption X25519 needs to go into that list. For encryption on the wire, it's less of a problem, I think, because you always have the context of you know who you're encrypting to, so you have the certificate. It's where we're trying to do capability negotiations. So in OAuth server configuration when I say I support a particular, ECDSA,
PS256.
PS256, that kind of works. So I think that we need to figure out, encryption is perhaps, we have to go through on a case by case basis, figure out whether or not it's worth doing. But I think that we still want to be able, even if it's not a runtime problem with ECDH, we should make sure that how we do configuration files is going to be clear. Maybe it's adding an extra parameter saying, yes, it's ECDH with these curves, or if you want to use a brain pool curve, what have you.
Don't laugh, Mike.
I knew it was coming. I didn't know they'd done it.
Okay, next slide. So should we do this and should it get approved, a result would be that this would add updated by references to some of the existing RFCs. In particular, 8037 that registered the EDDSA identifiers for Jose, it would add an updated by to the Jose algorithms draft. Justin asked the deprecating question, and that's a question that would come up, and I'm not taking a position. I would be happy if we deprecated. I understand it may not be practical, but that's a discussion to have once we have a working group draft and an intent to go down this road. But at least we would be doing updates so that implementers are put on notice that there's been some updates to the way that things are done here. Next. The other thing that I would propose to update is the instructions to the designated experts for both Jose and Jose, saying, please don't register any more polymorphic algorithms. Let's not make the existing problem worse. And so that's a section that I would write. Justin's on the queue.
Yeah, but if you're almost done, I'd rather you.
Okay, one more slide.
Go for it.
Next. A question somebody else asked me that I hadn't thought of, but it was a good question, is should this be a BCP document where it codifies the best current practice as described in the conversations with the CFRG, like make everything unambiguous, that's the best practice. And then that would be the core message of the draft. And a consequence of that is the rest of the draft would register some specific algorithms. I am not taking a position here. This is part of the thought space, and this presentation is about exploring the thought space with all of you great people. I am done.
Justin Richer, I have feelings about this last one, but that's something that needs to be discussed. The thing I wanted to bring up, though, and it was relevant to the last few slides, is that one of the tools that we do have available to us as a working group is updating the structure of an existing IANA registry. We can add columns and we can specify values for previously registered things in those columns. We can remove columns. We can restructure stuff that was already set up there by previous RFCs. And I think a lot of times the fact that that is allowable, it gets forgotten as a tool that we have at our disposal.
Like adding the polymorphic, non-polymorphic identifier column.
Exactly so. And so that would possibly sidestep the deprecating all the polymorphic question. Although that might also be something, I agree with Mike that that's a conversation that needs to be had in context of this work.
Yes.
Absolutely. But that might be an escape hatch. I am not an expert at how to do
I've done it.
IANA registries. I mean, ask Roman. But this is something that I think that is absolutely tractable.
Okay, just 1 second. I just wanted to point out Karsten has provided a draft in the chat that about the deprecation. He says to read that draft as well. So need to take a look at that. In case you're not.
Yeah, I'm typing to the chat because it's usually hard to influence an in-room discussion. So if you want to hear what I have to say, please look at the chat. Thank you.
And Yaron, can you pull that draft reference out of the chat and put it in the minutes, please? Or somebody else.
Brent Zundell, just wanted to say, from what I have heard, this sounds like a really good idea. I really like what Justin just said about adding columns, at least as an interim step toward cleaning up the polymorphic things, and would be very supportive of reading the draft.
Thank you, Brent.
Yeah, Mike Perek again. Just a quick follow-up. I think Justin's heading down possibly a really good direction here. In particular, we could possibly do things similar to what we see with RFCs, where we say updated by, et cetera. So we can approach similarly, right, where we can say this, use of this polymorphic existing is updated by this, or you should, replaced by, right? There might be similar language that we could figure out to point people the right direction going forward for new implementations. I would also note that there might be two separate items here. One might be guidance broader for writing specs around cryptography. We are seeing things like that come out of CFRG, out of the post-quantum groups as well. So we might want to look towards Roman and others to maybe coordinate some of those efforts so that we don't duplicate there.
And all of this validates why I'm glad I gave this talk about a draft that doesn't exist yet, because you all have context that I don't, and I'm really glad to get all of this input.
Any other questions? Okay, so your next steps are?
Write a draft. Circulate it to the mailing list.
Excellent. Okay, with that, we're at the end of the agenda. Does anybody have anything else? All right. You have a little bit of, oh, wait, I see hands. Go ahead.
Roman, if I'm out of bounds, tell me so. But I remember like an offhand comment that maybe you were going to think about making sure that we're chartered such that we can do Jose maintenance activities.
Yeah, I think that was also like we dropped the ball on that. Didn't you? You replied to the chairs, didn't you? Yeah. Yeah, go ahead.
Yes, as we left the conversation in IETF, we're at IETF117. So like at 16, the last time we met, there was ambiguity on whether maintenance was kind of in scope. I looked at it. Maintenance does not appear to be in scope, and that seems like a massive oversight. I think we can fix this with kind of one sentence, but to do that, we need to just formally recharter that. And the chairs and I kind of talked, and there was a proposal for what that one sentence would look like. And so we should run the traps quickly, in my opinion, to put it in there. And, we should obviously do the normal consensus process.
Thank you.
Right. Yeah. I was trying to decide whether to mention it or not, and I decided not to, but Mike. I know I do. Go ahead, Ari.
So just a brief comment about some recent documents that I think are relevant to the conversation we're having about, we're talking about algorithm, identifiers here, but they show up in envelopes and key formats. And I would like to sort of direct the attention towards the key formats that are supposed to represent a capability for post-quantum capabilities. So in particular, the key formats and Daisuke has worked on for HPKE, like how to express the HPKE parameters, thinking about key formats for some of these newer capabilities, and also key formats to support hybrid schemes, in both hybrid signatures and hybrid chems. Just there are some documents that have been posted to the list, right before IETF started, and you should, if you care about key formats, you should go take a look at them because they have some interesting JSON representation of some new keys you might be excited to use in the future. If you have comments, I'm sure the authors would love your feedback on them. I'll have to look them up, but yes.
Or the notes. Actually, the notes page would be great. All right. Go ahead, Michael.
Yeah, just one qualifier to add on to Ori's comments, which I think were great. And I agree with everything he just said, but there's one note that I think folks that aren't working in the space don't necessarily think of in relation to how we specify hybrids in the post-quantum side, which is the combiners also have to be very clearly specified, and they may have their own parameters, and they're not necessarily what we would think of as like a signature suite or something like that. So there is this kind of additional class of things that have to be specified to know what you're doing. So.
Okay. Are there any other questions or comments? As I mentioned at the top, please review the notes page to ensure that they are complete and accurate, because we'll pretty much copy that into the minutes for the meeting. And with that, you have 14 extra minutes in your day. So this thing does, and it's the same problem I had on Sunday. It works some of the time, and it does, because I was playing with it, and it does work, and then it doesn't work. It's like there's a certain amount of time you have to hold it down.
Playing with you.
That would be funny. That could be. I don't know. It's just not reliable. All right.
Because the ES256K registered as well, just which sets the pattern that future. Well, I think this will register. Well, that's what